Very good afternoon to you all. I welcome you for for today's session. Today's topic is programming for geocomputation with an introduction to introduction to Python. So in today's lecture, we will cover the basic concepts of programming, like what is programming, why do we need programming, and later on we will, in the first half of the lecture, I will be explaining you a theoretical part of the programming, and in the second part of this lecture we will see some basic geospatial data processing using Python. Like we will see how to read and write and do some elementary operation on raster as well as vector data. So after exploring the concept of programming, we will talk about basic elements of a program, like how do we construct a program, and or how do we write a program using simple commands. So then next we will cover some basics of Python. Built on these basics of Python, we will do some basic geoprocessing. Then we will explore the concept of geoprocessing, then explore Python ecosystem for geoprocessing. So in the last part of the lecture, I will be explaining you or introducing you to entire or a element or a basic ecosystem of Python available for geoprocessing. Actually, Python, if you see, Python has a very large ecosystem of libraries for geospatial data processing. So I will give you just a gist of that Python ecosystem for processing, so that you can use this for your learning objectives. Now, before starting, I will start with why it is programming. As all of you are aware that all the fields of science and engineering are becoming increasingly quantitative. So almost even not science and engineering only. So almost all the fields of humanities, they are becoming increasingly quantitative. So a lot of data is getting generated on the daily basis. So now for extracting useful information from that huge amount of data, so that can be made useful for humanities, so we need to do processing on that data. So suppose if you are going to do manually if you are going to manually process that data, even using some softwares, so it takes a lot of time and energy. So but if you know some basics of programming, so quite easily you can process a huge amount of data and extract useful information from that data. So if you know, so programming will help you in extracting data painlessly. So even now today, some people call like coding is the new literacy. So if you learn about coding, so then easily you can extract information from the huge pile of data available everywhere. Now processing larger data sets using numerical models and performing other quantitative tasks becomes quite easier with programming. If you are going to do manually, that is very cumbersome and error prone. So even after that, programming skills can help in collecting data, performing experiments, and analyzing the data, because manually analyzing huge amount of data is quite difficult. So if you know basics of, even if you know some elementary programming, so just with few just the basic knowledge of programming, you can analyze your data quite efficiently and very easily. So data pre-processing analysis can all be made more efficient using simple programs. As you see in our even in our daily life, like you after using internet, or even you can say, or you can take an example of online railway ticket booking itself. Earlier, manually you need to go to the railway station. From there you need to book the ticket. But now just at the comfort of your home, you can book your tickets or whatever you want. Most of the things can be done from your home itself. So on the background, everything, a program or a set of programs are working together to make your life easier. So programming helps in you in multiple ways. Now if we talk about computer, so what computer can do? Basically what computer can do, computer actually does not have it cannot think like humans. But what computer can do the calculations very fast. Plus it has a very huge memory available. Suppose if you are doing some calculations, you need to memorize or keep in memory results. So but computer has the advantage there that it has a huge memory, plus it can do calculations very fast. So like suppose if you are doing you are reading some 1,000 files or lakhs of files and you are processing something manually, so that takes a lot of time. So but with the help of computer, that things can be done quite easily, because computer can do even can execute billion of instructions in a fraction of second, plus it has a lot of memory. So computers are very fast in doing all those things. So if you see a basic model of a computer, it has some input devices for capturing data from the user. So input devices may be in the form of keyboard, mouse or screen. Then the data will be fed to a central processing unit, so which will be monitoring or controlling the flow of these execution of these programs. So control unit will be managing the flow of execution of the code or program what you have written. Plus it will have a ALU. ALU will be doing all the arithmetic operations. Then control unit will be managing all these operations. Plus it has a memory unit for storing those computations. Then once all the computations or your entire program has been run, then the output of the program is sent to the output device for maybe display or storage maybe. Then the computer may have some auxiliary storage device also. So basically with the input device, the data which needs to be processed will be captured from the input devices, and the central processing unit will be processing all these data, and the intermediate results or the all entire instructions will be stored in the memory, and from the memory it will be transferred to the ALU for processing. And finally once the entire processing is done, the output will be sent to the output device or maybe some file, or that can be stored in some auxiliary device as well. So this is a basic model of a computer. Now what is programming? Programming generally, if you see here you can see that I have attached a screenshot of a IDE or integrated development environment, and there some basic code is written. So before that, like, what is programming? Programming is also known as, some people will say, coding is the process of writing instruction to a device such as computer or a mobile device. So programming is like, suppose you have a problem at hand, and you know, like, these steps for solving this particular problem, I need to follow these steps. So with the help of programming, you write these instructions so that any computer or electronic device can execute those instructions. Because what happens, generally computers cannot understand the language which humans speak. So computers can understand a language developed for computers. So the instructions, so you need to write those instructions in the language of a computer, maybe some programming language. So the steps for solving a problem, altogether set of instructions for solving a problem, those things, this is called a program. So these instructions are written by a programming language. So then the popular names, so even program, the code is known by the popular names of program, or some people may say it computer program, or some application or app, or some people may refer it as an executable as well. So what is program? So program is just a set of instruction for doing some specific task. So what a program can be anything that is written with a programming language or a code. So what is program? A program that runs or executes code is carrying out some instruction. So what we are saying, that when a program is running, it is carrying out the instruction the operator or programmer has written. So like, suppose you have written instruction for calculating the simple interest given the principal amount and rate of interest or time. So for that you will write some instruction in a programming language, so that the computer should execute, like, some calculate this, multiply principal interest with rate and time, then divided by 100, and that will be called the interest. So this way these instructions you will write using a programming language. So a program will execute these instructions one by one and apply these instructions, and it may need some data to apply those instructions on. So that data also it will fetch from the memory, apply those instruction and return the results. So this is what is called programming. So programming means you are just writing the instruction to the computer for the computer to be followed by it, so that it can give you the desired your results, or it gives you whatever processing, it is like whatever processing steps you want the computer to do. So those steps you are writing in a language that computer can, you are writing those instructions in a language that computer can understand, is called programming. So programming language, what is now becomes programming language. As I explained here, computers cannot understand the language what we speak or we read and write. So for the computers, we need to write instructions in a language specifically being developed, or specifically the language which computer can understand. Though these languages are called the programming languages. So programming languages are vehicles for communication between human and computers. So like for interacting with the computer, we need to know the language which computer can understand. So that is called a programming language. So the principal purpose of programming language is for developers to build instructions to send to a device. So the programming languages are developed so that we can make an interface between a human and the computer. So programming languages come in a variety of formats and can serve different purposes. So actually there are a different type of programming languages. Some languages called low-level languages. So like here you can see that low-level languages, these are just machine-readable languages. It is very difficult for a human to understand these languages. So these are the instructions are written, very primitive instructions are written in a machine language, like add, move. So these basic instructions are written, that is called machine language. So ultimately this machine language needs to be converted to the binary code in the forms of 1 and 0s, which a computer can understand. And there are other languages called high level languages. So these languages are quite close to our English. So these are called high level languages, maybe like Java, Python, or JavaScript. So like here in the top here you can see that these instructions, so these are very abstract languages. So here we can write instruction as quite close to English. So but ultimately these instructions also will be converted to the machine language, so that the computer can interpret or execute those instructions. So ultimately these also will be, this is a converted to low level language for execution on a computer. So now what is a program? So what you say, a program is a sequence of instructions that specifies how to perform a computation. So you may need to perform a computation. So now you need to communicate it to the computer. So how do you communicate it to a computer? Like these instructions must be followed, like add these two numbers, subtract these two numbers, or multiply, like this. So what is a program? Program is a sequence of instructions that specify what needs to be done in a language that computer can understand. So a single instruction in a program is called a statement. So a program is a set of statements. So so when you have very simple problems can be solved using a single instruction. But when you have a larger problem, even a non-trivial problem at hand, you will need a set of statements to get the solution of that problem. So you need to write a program. So your program will have multiple statements. Then there is another term comes in called variable. So the data is stored, like when you solve some equations, you use variables in algebra. So similarly variables exist in a program as well. So these variables store the data which can change or may not change, depends on how you have defined your variable in the code. So all your data will be stored in the variables, and your program will be manipulating those variables to get the desired result, and you will be writing the statements to modify or do some processing on those variables. So that is called a program. So in program you will be writing the instructions to modify those variables or state of these variables to reach the result. So and then there will be a flow control. So controlling the flow of an application is called flow control. So what may be happen, so depending on the state or value of the variable, you may ask the computer to follow certain instructions, or in certain cases you want it to skip certain instructions. So that is called the flow control. So in the next slide we will be talking more about this flow control. So a program basically will be a set of statements for execution. So the program in those statements, the statements will contain executable code to modify or modify some variables. So now comes Python. What is Python? So as I explained, there are multiple types of programming languages. So Python is one of the programming languages, one of the popular programming languages. So if you see, Python is one of the most popular high-level programming languages in the world. So actually Python has been, Python is picking up very fast. So till I think 1 or 2 years back, Java was one of the most popular programming languages. But now Python has picked up with the advent of because of its easiness. Now Python is picking up very fast. So Python has become now the most popular programming language in the world. Plus it enjoys a wide range of uses, from automating repetitive tasks and writing web apps to building machine learning models and implementing neural networks. So Python, as I explained in my previous slide, that there are a lot of programming languages. Some programming languages are written for some specific tasks. So like JavaScript. JavaScript is mainly used for web programming. So similar way, assembly language or C, they are for hardware, interacting with hardware. But Python can be used for almost all. It has a wide range of uses. So even you can write web applications, desktop applications. You can write even Android apps using Python. Then you can build machine learning models, deep learning models, and implement neural networks in the Python. So Python has a wide range of uses. So any application you talk about, Python can be used for almost all those applications. Even for web application like Django, there are multiple frameworks. For machine learning or deep learning, you can say PyTorch, TensorFlow. So all are based on Python. Plus, Python has a very simple, easy to learn syntax which emphasizes readability. So the developers of Python emphasized on readability, so that the language must be readable by human. So you need not to be a special computer to understand the code of Python. So when you start writing the code, it looks quite similar to English. So when you are writing code in Python, so because the readability emphasis was on readability, so Python code can be quite easily be read even by. So how Python runs? So once you write the instructions in a interactive console, or you can save your instructions in a .py or Python file, that instructions will be interpreted by a Python interpreter. So Python interpreter will convert your or interpret your code for the computer, so that the computer can execute it. So the Python interpreter will convert your Python instruction written in Python to a byte code. So that will be interpreted by Python. Python interpreter will convert to bytecode, and that will be finally executed by the central processing unit or your computer, and you will finally get the results. So Python is a interpreted language. So now next comes why we need to study Python. So one of the basic reason is Python is widely used. As I explained, so Python can be used on all. Python can be used in all sites, like whether you are going for web application development, desktop application development, or deep learning, machine learning, image processing, any field you take, Python can be used in all the areas. Then the second reason is Python is open source and free. So you need not pay anything for using Python. It is open source, and even if you want to make some changes to the Python, you can change, you can freely use, you need not pay anything. Then the most compelling reason for using Python, what I feel, is Python is friendly and easy to learn. So as I explained, the emphasis of the Python developers was on readability, so that it doesn't become difficult to read the code. So you can even without much experience, you can quite easily read and understand a Python code. Then you can learn also new constructs quite easily. So that is the most compelling reason for using Python. Its friendliness and easiness to the learn. The next is Python is powerful and fast. So actually, though Python is an interpreted language, but it's quite fast as it is fast as comparable to Java, but it will be a bit slower, but it is at par with Java or C++ you can take. It lets you work more easily and integrate systems quite easily. So anyway, because it's easy to learn, so you can work on it very easily, and even like different components you can integrate all them together very easily, because all multiple people can work all together, and the subsystems can be integrated quite easily. Plus Python's documentation, tutorials, Python has a large community base, so they are updating the documentation, tutorials, guides continuously. So almost every alternate day you will be getting updates on these documentations, and they are evolving with a great community support. Python has a great ecosystem for all the things, and those things are evolving. So this is also one of the reasons why we can switch to Python. Now next comes, why should we use Python for geospatial data? As explained, Python has an extensive ecosystem of libraries and tools for geospatial data as well. So geospatial data processing is just a subset of entire Python ecosystem. So Python has quite extensive support for geospatial data processing also. So whether you need to process raster data, vector data, network, anything you name, you will have associated libraries supported by Python. Then similar to other basic Python libraries, Python geospatial libraries are also quite easy to learn, because these are based on the Python, so it is quite easy. Then friendliness and easy to learn. And Python is highly efficient. So you can write quite efficient code using Python. Then Python is highly flexible. So you can plus it runs on any environment, any platform. You write Python code in a Windows computer, seamlessly it runs on the Python or Mac, Solaris, any of the operating system. So it's platform independent, highly flexible. Flexible means actually you can say that you can combine it with other programming languages also quite easily. So Python code you can combine with Java using Jython, .NET also you can combine. So Python is highly flexible as well. You can understand more deeply. You can learn. If you start using Python, you will learn and understand more deeply. You can plug in and chain different third-party softwares. Also can be quite like if they have APIs, so you can plug in and combine multiple third-party softwares also quite easily using Python. And Python libraries are developing fast. So every day or alternate day, you get new features added to the Python libraries, which make your programming tasks much easier. So these are the reasons why people are using Python, and so why Python is so popular among even data science community. Actually, Python is most popular among data science community. So Python implementations, like you see different implementations of C programming language like Turbo C, NCC, and others. So similar way, Python has multiple implementations available. So depending on your requirements, you can choose which implementation of Python you are comfortable with. Like these are the different implementations which are popular among community. So first is CPython. This is the reference implementation. So this is commonly used for web development, application development, and basic scripting. So this is the most popular Python implementation available. So this whatever you download from the python.org, this is the CPython implementation. So this is the most used implementation of Python. You just go to the python.org and download it, the CPython implementation from there. The next popular Python implementation is Anaconda. So this Anaconda is a specialized Python distribution tailored for scientific programming tasks. So this is popular among the data science community. So there are a lot of data science libraries available in Anaconda, implementation of Python available. So if you are a data science enthusiast, you can use Anaconda Python, because Anaconda is a Python package manager as well as an environment manager as well. So this is popular among, so even all deep learning libraries, everything is available on this. So if you are a data science enthusiast, you can switch over to the Anaconda Python. Then there is an Iron Python. So Iron Python is an open source implementation of Python built on .NET runtime. So if you are interested in running on the .NET runtime, you can switch, you can explore Iron Python. Then Jupyter Notebook. So Jupyter Notebook is a web-based interactive programming environment widely used in research and academia for mathematical modeling, machine learning, statistical analysis, and so on. So for writing your code or reaching out to the new people, like for explaining code and so, you can use Jupyter Notebook also. This is a web-based interactive programming environment which supports multiple languages. So Python is one of the languages supported by Jupyter Notebook. So mostly in data science community or geospatial community, people are using Anaconda Python or C Python. So now this was the basic introduction about Python. So anyway, now I will, before going into details of geospatial data processing, I will just, for the sake of, because this you might have got it in your previous lectures also, I will just cover a basic of geospatial data. What is geospatial data before going to the processing details of the geospatial data. So what is geospatial data? Geospatial data is information that describes events, objects or other features with a location on or near the surface of Earth. So geospatial data, you can say that is the information that associates location information with the objects or events or features with the about which the information is being presented. Like we can see that this is a image of some city here. So this data, when we attach location, latitude and longitude of these this area with this image, then we call it a geospatial data. So typically combines location information and attribute information with this data as well as, like we can attach the name of the city, where it is located, how many houses are there in this, which country it belongs to, and so on. So this data is called geospatial data. So the location provided with this geospatial data may be static or it may be dynamic, like when the vehicle is moving. So then you can see the location of the vehicle may be updating when you see on the Google map or somewhere. So this geospatial data can be represented either using raster or vector. Now suppose if you see here this particular real world data, this can be represented either using raster, like a cell of grids. So like this is like when you take and top view image of this area. So either you can represent it using image using grid of cells, or it can be represented as boundaries or vector data as well, like the city can be represented as a polygon or a point, or these buildings can, like river, canal, these can be represented with lines and so on. So this data can be represented, can be either raster or vector. So basically there are two types of geospatial data. When we attach the location information with your data, this is called geospatial data. So there are basically two types of geospatial data. One is called vector data and another is called raster data. So vector data is a representation of spatial elements through its x and y coordinates. When there are distinct boundaries, like if you see in this data here, when we are representing this as clear boundaries like the boundary of city, so this is called vector data. So vector data can be represented either using a point, line or polygon. So like a city can be represented as a point, or a river or a road can be represented with a line, or footprint of a building or boundaries of a country or city can be represented using a polygon. So the data is made up of point, line and polygon. So raster data, similarly raster data are 2 or 3 dimensional arrays of values. So the data sets are suited for any continuous data. So whenever your data is in continuous form, like here you can say this is showing the temperature of entire India. So temperature is generally a continuous value. So this can be represented using cell of grids or matrix using a raster data. So next term comes geoprocessing. So as we say, geospatial data can be raster or vector data. So geoprocessing is manipulating the spatial or geospatial data, whether raster or vector, in some way to extract some useful information from that data is called geoprocessing. So geoprocessing is or even geoprocessing can be a framework and set of tools for processing geographic and related data. So like here you can see an example. This is taken from Bhuvan. Like you are standing in some place and you want to see which all Aadhaar centers are in your vicinity, and just you want to find a route to the nearest Aadhaar center. So that is also a kind of geoprocessing. Or you want to extract some information from, or like suppose you want to classify some image. So that can be also image processing. Like you want to extract how many buildings are available in this my particular image. You want to do it using image processing or some deep learning approach. So extracting some useful information from geospatial data is called geoprocessing. So this was all about geoprocessing. Now I will just cover some basics of Python. Then we will see how do we do this basic geoprocessing using Python. So as I explained in my previous slides, so the basic construct in a programming language is variable. Variable is one of the most powerful concept in a programming language. So generally when you say there are certain values in a program, like that it may be temperature or some x or y, some value. So when you associate a name to a value, that is called a variable. So you may need to manipulate that value later in your program. So value, when you are assigning a name to a value, is called a variable. Like here you can see here we have a value of 1. So this 1 may be anything, like number of buses available in IIRS campus right now, or some any variable. So it has a value of 1. So when I am assigning this, I am attaching it to x. This can be assigned like x equal to 1. So here what I am doing, I am making a variable x and assigning it a value 1. Or you can say it another way, that one value has been assigned to variable x, or where we have associated a name of x to this value 1. So in Python, variables can be defined like just the name of the variable and with the assignment operator and the what value you want to assign to it. So x may be 1, and then later on, suppose if you want to another variable y, that you want like y equal to x plus 5 and z. So this way you can define variables. So variable name, and then it's assigned whatever value you want to assign. So like in other programming languages, if you have worked in Java or C, there you need to define the type of variable as well. Maybe it is an integer or floating point or character value. So, but in Python you need not, and even you can, these types of variables are dynamic. You can change the type quite easy in the next instruction. So this way we define the variables in Python. So Python has different data types. One is called number. So numbers can be either integer or floating point numbers. So you can write x equal to 1 or x equal to 1.0. So if you write x equal to 1, or then if you print type of x, it returns you integer. So similarly, strings can be strings. So strings are a set of characters. So strings are defined using parentheses or using inverted commas or single quote or quotation marks. So strings can be defined using single quotes, double quotes, or triple quotes. So either way you can define strings. So once and you have, suppose here I have installed Anaconda in my system. So if I go to start and type Anaconda prompt, so Anaconda starts here. So for starting Python, I can just write Python here. So the Python starts. So and here I can write like x equal to 1. Then I can just say print x. So this way I can, so Python interpreter, or you can write your code in Jupyter notebook. So For geoprocessing, I will be using Jupyter Notebook. I'll explain as we go ahead. So this is with numbers. This way you can define numbers. Now, suppose if you have to define a function in Python. So what is a function? So a function is a reusable code when you are combining multiple instructions together and making it a reusable code so that it can be called in different parts of program. That is called a function. So how do we define a function in Python? So in functions in Python are defined using the def keyword. So def, then the name of the function, and in parenthesis, then if your program takes some arguments, then you need to define inside those parentheses, otherwise you can leave it blank. So def, then name of your function, then a colon, then the instruction inside the function will be indented, means we will leave 4 number of spaces between this def and this print, so that indentation level, like in other programming languages, we make indentation using the block of codes are identified using curly brackets. But in Python, we are not using curly braces for defining a block of code. A block of code is defined using indentation level. Indentation means level more number of spaces. So here you can see that this print statement has more number of spaces left. So it means that this print statement is part of this function definition. So indentation level defines the block of code in Python. So once a function is defined, how do we call a function? Because once a defined function doesn't do anything on itself. So we need to call that function. So at rocket parts, I have defined a function like it prints payload, propellant and structure. So now suppose if I want to call this function, I need to rocket parts, name of this function, and this parenthesis. So with this we are calling this function. Here we are defining the rocket parts, we are calling this function, and this just prints whatever this function is supposed to read. It was supposed to print payload, propellant and structure. If I call it here, it prints this this line, payload, propellant and structures. Now functions can take some arguments as well. So this rocket parts function was not taking an arguments. Now suppose if you want to define a function which takes arguments, you can define it like similar way. Only thing that inside the parenthesis you can pass the arguments which it expects or takes. Like here it is taking an argument called destination. So like distance from Earth, destination, if destination is equal to moon, this is a flow control statement. So if statements in Python are written in this way, if then your condition which you want to evaluate, and a colon, then a different indentation level, because this return statements belong to this if block. So this will be at more indentation level than else. So else is coming at the level of if, because this is not part of this if block. Then else, then inside else, if this condition doesn't hold true, then it should be unable to reach destination. Now similarly, how do we call this function? We call the same way distance from Earth, and pass it the argument which it is expecting. So this way we can call any Python function. Now I will just briefly explain you about Python ecosystem for raster processing. So if you are interested in processing raster data using Python, so there are multiple libraries available in Python. So one of the most prevalent or versatile library available in Python is for raster data, raster or vector. Actually, it can process both type of data, that is GDAL. So GDAL or Geo Data Abstraction Library. So GDAL is the most versatile raster or geoprocessing geodata processing library. So if you want to master geospatial data processing, so raster is the first step for going towards that. So you can so there are a lot of proprietary softwares are built on the top of GDAL. So there are a lot of libraries like XArray, raster.io. Then there are many other libraries I will explain in detail. So there is you can see the name of libraries which can be used for raster data processing. Then similar way, there are a lot of libraries for vector processing as well. So GDAL can be used for both raster as well as vector. Then for raster processing, vector processing, these are the libraries like GeoPandas, Shapely, Fiona, and so on. So these are the libraries, and I will cover in detail now next. Now these are the libraries, like suppose if for geospatial analysis. So GDAL is the most versatile among them. So all the vector as well as raster data formats, almost all vector and raster formats are supported by GDAL. So GDAL is the most versatile library. Apart from GDAL, there are libraries like Whitebox. Suppose if you are interested in doing LiDAR data processing, so LiDAR Python library is available. For geospatial analysis, PyGIS, or suppose if you are using ArcGIS, this is a proprietary software. ArcGIS software also has APIs for Python. Then Raster.io is also quite popular for vector as well as raster data processing. Then suppose if you are working on Earth Engine, Google Earth Engine API is also available. EarthPy, Fiona, GEUp. Suppose if you are working on GeoJSON data, then GeoJSON area, GeoJSON IO, and for vector data, GeoPandas is a good or quite easy tool for vector data processing. GPI, suppose if you are interested in geospatial image processing for Python. GPD Vega. So GPD Vega is a bridge between GeoPandas and Altair. Altair is a language for visualization. So with GPD Vega can bridge together GeoPandas and Altair. So you get the features of both. So suppose if you want to make geospatial chart for geospatial data, so GPD Vega also you can use. Mapbox GL. Suppose if you are interested in network analysis, NetworkX, OSMNet, Panda Network, and Panda also has a framework for network analysis, Panda NA, PeerTree, PyGDAL. Then if you are 3D analysis, PyMap 3D, PyCF, PyProject. Suppose if you are in spatial analysis, PySal you can use for shape files, just reading and writing. PySSP, Raster.io, Raster Stats, RIO, CogGeo, Rio Color, Histogram. So there are so many libraries available. You can go through this. Sentinel Sat, Sentinel Hub, Xarray also is becoming quite popular. So these are the libraries for geospatial analysis. There is a similar way. Suppose if you are interested in mapping and plotting, so the most basic library on which all these libraries are built is Matplotlib. So based on the top of Matplotlib, there are multiple libraries like Basemap, Bokeh, Cartopy. Cartopy is a library for providing cartographic. Bokeh is for interactive web plotting. Then Cartopy is for cartographic tools for Python for plotting large scale data. Descarates, Geoplots, GeoPy. Geoplot also is quite good for vector data plotting. GeoPy you can use. Folium is a leaflet based library for creating maps. Then MPL leaflet, PyWPS, PyCSW, IPY leaflet. So there are multiple libraries for plotting or processing. So this was all about these different libraries. Now I will demonstrate. I will show you a basic, like whatever we have learned basics of Python, just based on those basic variables and simple basic functions. How do we read and write raster data or vector data using Python? For this, either you can I will be using Jupyter Notebook. So either you can install Jupyter Notebook using Anaconda on your local system, or suppose if you don't want to install anything on your local system, for that there is an option available called Google Colab. So Google Colab is Google Collaboratory. It is a Jupyter Notebook environment hosted on the Google Cloud. So for this you need not install anything on your system. You need just an Google account and internet connectivity with a browser, any browser, maybe Firefox or Chrome. So for accessing Google Colab, you need to just search Google Colab on your Python on your browser internet. So if you search Google Colab, so it gives you a link to Google Colab, colab.research.google Colab. So here you get a virtual machine with almost 12 GB of RAM and a good processor. Then you have GPU also available with Google Colab. Now suppose if you are doing some deep learning works, you can do. So once you go Google Colab, you can just sign in using your Google username and password. Once you sign in, so I have already signed into my account. Once you sign in, you will get something like this. So this, once you get this, you can go to the new file, new notebook. So once you create a new notebook, you will get like this. So in Google Colab, actually what happens for using these whatever libraries I explained like GDAL or XArray, raster IO, you need to first install those libraries in your system. But what in case of Google Colab, there are almost all the libraries which you need are already installed, pre-installed in Google Colab. So you need not even install anything there. So you need to just sign into the system and you can just start writing your code. So before that, I will explain you what is Jupyter Notebook. So Jupyter Notebook is just like a notebook you are writing, like just a notebook for writing. In a Jupyter Notebook, you can write code, you can insert images. So Google Notebook, this Jupyter Notebook, just like you are writing code on your notebook. With code, you can write explanation for your code. You can insert images, and even when you run the code, you can save intermediate outputs or intermediate images. Like in another programs, when you are running, you cannot save intermediate outputs. Your program will run one by one, and your previous outputs will be overwritten. But in Jupyter Notebook, you can write notes, insert images, save intermediate outputs. So, and you can make presentation out of those notebooks. You can share those notebooks with your friends so that they also can, or you can collaboratively work on the same notebook, all of you. So now once this is done, so you can just click on the connect. So connect will connect to Google in Google your Google Colab to your notebook environment. Once this is done, so then actually this Google Colab can access your Google Drive also. So if you have some images to be processed, you can save your images on your Google Drive, and Google Colab can access the Google data from Google Drive as well. So if you see in the Google Colab, there are two types of cells. One is called code cell and another cell is called text cell. So like here you can see that this is a type of text cell. So here you can write instructions in Markdown language. Markdown is a formatting language where you can write formatted text. You can, suppose if you are interested in writing equations or some HTML type of text, so you can use, so for that you need to learn basics of Markdown. So here there are two types of cell. One is code cell and text cell. So from here you can insert which type of cell you want to insert, plus code or plus text. So plus text you can write formatted text, and in the plus code you will write executable Python code. So like here you can see I have created a cell of text cell and I have created a heading like raster data processing using Python. If I see it, I have written it like with Markdown I need to use hash, then it will be interpreted as a heading. So raster data processing, then this cell is a code cell. So here I have written Python code. So in the before using Python, what you need to do, actually what happens when the Python interpreter, because Python has a huge ecosystem of libraries. So what happens when the Python interpreter loads at first, it doesn't load all the libraries. So it just loads libraries which are essential or basic Python libraries. Now, so all functionality of the Python is not imported into the Python interpreter at first instant itself, because that will just delay the process of loading, and everything will not be required by everyone. So for efficiency as well, for everything is not loaded. Now suppose if you want to build or import new functionalities to your Python interpreter, you need to import certain packages. So for that, this is the syntax like from OSGeo. OSGeo is like a package. Package means a file package is a module which contains multiple files. It can contain multiple files which contains different Python functions. So like from OSGeo package, we are just importing a GDAL module. Then like suppose this is GDAL, as I explained, GDAL is the library most versatile library for raster as well as vector data processing. So I am first importing that GDAL library. So OSGeo, if you are using your local system, then you need to install this. Otherwise, with Google Colab, in Google Colab, this is already installed. So from OSGeo, I am importing GDAL, then matplotlib.pyplot as PLT. This is for matplotlib is for visualization. Then NumPy anyway is not required right now. So now here I have stored my data in my Google Drive. In Google Drive. So Google Drive also, suppose if you have Google Drive, you can just like I will. So for loading the Google Drive, you can just click on this drive icon here. Then your Google, it gives a code. Then just after authentication, your drive gets loaded here. So here I have stored some data in my drive in data folder. In data folder, I have saved some vector as well as raster data. So here I am giving like my file name. So the data is available in my drive. So I have a vector data multiband TIFF file. So this is a 3 or 4 band TIFF file of Haridwar area available in me. Now I will see that how do we read this file using GDAL. So I have defined a variable called file name. In the file name variable, I am storing the path of my file or the full name of my full path of my file where the data is stored inside content directory, drive, my drive, data and multiband.tiff. So I have just defined a variable named file name in which I have stored the name of file which I am interested in reading. Now as I have imported the GDAL module, so now for opening a file I need to call this function GDAL.open. I need to execute this instruction GDAL.open and pass it the name of file which I want to read. So GDAL.open, then file name construct file GDAL. So if I run this instruction, it means if it is DS, so it means now if I just print DS, so it says that if it is printing this osgeo.didal.dataset, it means that the file is read properly. So now the file has been written and it has returned us a data set. Now from this data set, now suppose if you want to know like which all files you have read. So this is a function called ds.getFileList, which returns all the files associated with this data set. So here our file was this, so it has returned like this. This driver has read this file data.multiband.tiff. Now this is a multiband TIFF. So this will have multiple cells arranged in a grid. Now suppose if you want to know how many rows of pixels and how many columns of pixels are available in this particular image which we have read. Now suppose if you want to query that, then we can call this function on this ds, whatever this ds was returned, ds.raster size x. So this returns the width or number of pixels in x direction. So how many pixels available in our width of our image. So it says 1151. So in our image there were 1151 pixels. Similar way we can raster y size. We can return the number of pixels in y direction. Now suppose if you want to read about the projection information, like in which projection the image data is stored. So that if you want to extract, you can call ds.getProjection. So ds.getProjection fetches you the projection information associated with your image. So it says it is Geographic Coordinate System WGS84 in with WGS84 datum, and this is the spiral details and this. So this way you can read the projection information for your image using your dataset.get projection method. Similar way, now suppose if you want to get the or affine transformation, you want interested in extract the affine transformation information associated with your image, that can be extracted using get geotransform method. So ds.getGeotransform. So this geotransform is a 6-element tuple. So first is the longitude of x 00th pixel longitude. Then this is the a resolution in spatial resolution in x direction, then this is the rotation. If north is up in your image, if north is pointing to up your image, like whether your image is rotated or not. So if north is directly up in your image, then this number will be 0. If your image is slightly rotated, then this number may reflect that rotation. So longitude of 0th pixel, spatial resolution in x direction, and the rotation. Then this is latitude of y pixel, rotation in y direction, and this is resolution in y direction. So with this, suppose with this geo-transformation information, suppose if you want to calculate the real world coordinates of your pixels, so that can be done using apply geo-transform function. Apply geo-transform function takes 3 arguments. One is your geo-transform GT and row number and pixel number. So this way you can calculate the coordinates of upper corner, upper left corner, upper right, lower left, lower right, or center of your center pixel of your image, just by calling gdal.apply geo-transform. So here now you can see that these are the coordinates of upper left corner 77.99 and 30. So this is the latitude and longitude of our left, this is the upper right, left, and this is the coordinates of center point. Similarly, what happens generally when you download raster data from some website, so you will get associated metadata of that data as well. So that metadata also can be read using GDA I calling ds.get metadata function. With this get metadata function, you can get the metadata of that data also. Similarly, now suppose if you want to know how many bands are available in your image, then you can just call this function ds.get raster count. So this way you can get, like, this is a 4-band image. Now suppose if you are interested in getting the statistics of all of the bands in your image. So what you can do, you can loop over all the bands one by one, and there is a function called band.compute statistics. So with that band.compute statistics, you can calculate the statistics of every band of your image. So here what I am doing here, I am looping for I in range 1 to ds.raster count. So what happens generally in computer science, indexes start from 0, but in case of GDAL, the indexes of band start with number 1. So this for so the for loop is written in Python like this: for I in range, like starting number to ending number. So this way. So similarly, I am running here a for loop for I in range 1 to ds.raster count plus 1. So in my image, if there are 3 bands, this 4 bands, this loop will run from 1 to 5, means 1 to 4. Then what I am doing here, first I need, from the data set, I need to fetch that individual band. So for fetching the individual band from the data set, which was returned by gdal.open, we need to call the function ds.getRasterBand. So if you call ds.getRasterBand and pass it the band number which you want to fetch, it fetches you a band. So ds.getRasterBand, and it returns a band. Then on this band you can call the function band.compute statistics. Now this is like compute this, we are passing it an argument called false. So if you don't pass it false, so what will these statistics will be calculated from an overview image. So we don't want the statistics to be computed from an overview image, we want the statistics to be computed from the original image, so or image at the native resolution. So we are passing it an argument false. So compute statistic returns 4 elements: minimum, maximum, mean, and standard deviation. So when this is done, we are printing those minimum, maximum, and standard deviation. Then this will go for the next band. So this way we can see the statistics for each of the bands. So now here you can say for band 1, minimum pixel intensity was 61, max 217, mean was 93, standard deviation was 14. Similar way for other bands. Now this we have just read the data. Now suppose if you want to visualize how does our image look like. Now first we will visualize a single band from our image, then we will visualize all bands together. So now similar way, now first we need to fetch the particular band which we want to visualize, ds.get raster band. So I am fetching band 1. Now there is a function. So anyway, as we said that every raster image is a 2-dimensional or 3-dimensional matrix of numbers. So for fetching that matrix, we need to call on this band.read_as_array. So band.read_as_array will return us a 2-dimensional array of numbers which denote which is depicted, which depicts the image. So data equal to band.read_as_array. Now this band, this is this data. Suppose if I print it, this is a 2-dimensional array of numbers. So these are the numbers. This is showing the intensity of pixel 1, intensity of pixel 2, 3, and so on. So this is the data. Now let us visualize this. How does it look in an image? Because ultimately this is how it is stored in computer's memory, but for visualizing we need to represent it as an image. For that visualization we have to use this function, this Python package called matplotlib. So matplotlib has a function, pyplot function has a function plt.imshow. plt.imshow print or displays a 2-dimensional array. So imshow we are passing the argument of this variable data, and then this is the color map, grayscale or any other color map you can show. So here you can see the image. So this way you can fetch a individual band from the image and display it using GDAL or matplotlib. So similar way, this was a single band. Now similar way we can fetch all the bands together and visualize a composite image. So similar way we can use, only here we need to pass the all 3 bands together. Now here you can say that this so by changing the order of these bands you can make different type of false color composites from this particular image. So this way you can visualize single band or multi-band raster. So similar way you can use other bands for visualizing other standard false color composition you can make on. So you can make a standard false color composition and so on. So once this is done, you can just call plt.close. So this is the way how do we read a raster image using GDAL. So for that, first you need to import GDAL to your Python interpreter, then call GDAL.open. So GDAL.open and pass it the name of file which you want to read. So that will return you a data set. On that data set you can fetch individual bands by calling the function that dataset.getRasterBand, then passing in the argument which particular band you want to fetch on that band, then you can read it as array. Now this is an NumPy array. So you can do any kind of manipulation or any kind of image processing on this NumPy array. You can do edge detection. You can calculate some indices from combining 2-3 bands. You can classify this image and so on. So whatever you wish to, or you can mask pixels below certain value or pixels subsaturated or mask saturated pixels. So whatever you want to do, this is an NumPy array. You can do that. That is called geoprocessing. So now after this we will see that how do we read vector data using GeoPandas. So vector data we will not use GDAL. GDAL also can be used for this, but GeoPandas is much easier than GDAL for vector data. So for this, what happens, GeoPandas is not coming a priori installed in Google Colab. So for that we need to first install. So for installing, like pip install GDAL. So you need to use this exclamatory mark. So this exclamatory mark means this is not a Python command, this is a system command. So pip.install is a system command. If I do this, so the GeoPanda gets installed in my Google Colab. So this way you can install any other library also. If you find that whatever library you need is not available in Google Colab by default, then just by using pip you can install the libraries as well. Now if you talk about vector data formats, vector data also comes in multiple formats. So one of the most common or popular format for vector data is ESRI shapefile. So this is a simple non-topological format for storing geometric location and attribute information of geographic features. So the save file by default with save file will have multiple auxiliary files with this, like files with s.shp, .sxx, dvf, sbn and sbx and prj. So these all files are required for reading a shape file. Then there is another popular format for shape file is GeoJSON. So in GeoJSON, all the data, all entire vector data is stored in a single file. So as a similar way, GeoPandas also is not imported automatically. So first we need to import those files. So now if you see here in my folder, in my data folder, I have these India state boundaries.dpf, prj, qpj, shp and sx. These are the files available inside my data folder. So these are the state boundaries of India. So we will see how to read a shape file using GeoPandas and visualize it. So for this, we will first import GeoPandas package, import GeoPandas as GPD. Then NumPy is not required actually. Pandas also may not be required. Then we need matplotlib and GeoPandas series if required. We will use, otherwise may not be required. So like raster data, here also I have defined a variable called vector file. Vector file is storing the name of file which we want to read. So in the content drive, my drive data, India shape boundary.shp file is available which we want to read. So vector file. Now similar to GDAL, here also GeoPandas gpd dot read underscore file. There GDAL dot open, here gpd dot read underscore file, and pass it the name of file which you want to read. So vector file is a variable which is storing the name of the file. So if I say India, so now suppose if you want to see how the file looks like, India.head. So India.head, if you call, initial 5 rows from the data is shown. So this India file has this associated attribute table attached to this. So with every polygon there is a length and area attribute attached to every polygon. So this is, can see. So now if I just don't give head, then entire attribute table will be printed with all polygons. So here you can say that all polygons got printed. Now suppose if you want to know what is the CRS, so then your India variable dot CRS you can call and get the coordinate reference system associated with your image. So this is in geographic APSC 4326 WGS 84 coordinate system. Now this is about attribute. Now suppose if you want to visualize like how these boundaries look like when it is combined. So similar thing like you can call India.plot. Just you need not do anything else. Just your variable which is storing the India geo data frame, India.plot. Color you can specify like there, like if you want to be this being, otherwise by default it will come in a color. So here you can say, see that the entire save file got printed on the screen. Now suppose if you are not happy with this particular color and you want to change the color, you can pass the argument color equal to green, red or whatever you want. This way you can plot the image. Then there is another, like if you want to change the edge color to red and the face color to none, then you can call same India.plot edge color. You can specify like I want red color and face color like no filling. So this way you can see that India's plot with red color and no color filled on the face. So this way you can modify the visuals of your vector data. So once this is done, finally you can close your image. So this is introduction to the vector data processing. So as I explained, so vector data can be read using GeoPandas, and raster data can be read using JDAL. So quite you need to follow a few very basic steps. JDAL.open, similar with GPD or GeoPandas.read file. Then for visualizing .plot this way, and there you once you read raster data, you get a two-dimensional array of matrices that you can manipulate. So this is all about today's lecture. So thank you very much. Now you can post your questions. So after 5 minutes of break, we will take up questions.